Okay, guys, we're getting back to work. Now we're looking at a section called perfect squares, okay, which is just a simplified way of simplifying a certain subgroup of these examples. So I'll just go straight to the box to show you guys what the rules are. If you have something which can be written of the form shown up here, a squared plus 2ab plus b squared, then you can factor it as a plus b all squared. Right, again, if you don't want to worry about this, you don't have to, because the old methods we learned will always work. This is just a way to simplify our life a little bit. So let's see if we can look at an example. A squared plus 2ab plus b squared. Okay. Let's see if this first example, x squared plus 6x plus 9, can be written in that form. Can it? Let's see. I think so. Yeah, because the a in this case would be 1. The b would be 3. Will that work? Let's see. I'm looking at this one up here. So I'm comparing the rules down here, right? Okay, so the rules come with some examples to look at if you want. The examples are right here. If you have something of this form, it can be factored like this, right? So the form above, a squared plus 2ab plus b squared, right? So, I mean, it's clear from this form here that this is a squared, so a itself will be 2, right? This is b squared, so b itself will be 5. So that's why you got a 2 and a 5 here. So again, you don't have to worry about this if you don't want to, but if you can spot these things, it helps you to simplify them in one step. Right? So there's a few sections here I'm going to leave for you guys to try at home. This is one of them, the perfect squares, because you don't have to know this. Right? This helps you to simplify things quickly, but if you don't like it, it's okay. You can just use the methods we've been using already. So perfect squares is one of them. Maybe we should try this one here, using the simplified method. How would you guys rewrite this? Okay, let's show the rules above so we can look at it. 3. I'll go with 3. I think 3 is fine. Let's start with 3. Or should it be 3x, I think, right? Because it's 9x squared here. So the square root of that is 3x. Okay. So let's go with it. 3x minus 4, right? I think 4 would work. If we're not sure, we can always check it by opening up the brackets. Squared, right? We should square. If we open up the brackets, do we get back to the original? I think so, but let's check it. If I write 3x minus 4, 3x minus 4, let's see what happens. We'll end up here with 9x squared on that side, which is a good start. 4, 8, 12. So we get minus 12x minus 12x plus 16. Yeah, so that works, right? That will simplify. So that's just a good way to check it if you need to. Okay, so again, we're just using the rules given in the box. Okay, and I think this also should be a read at home, factoring a difference of squares. Okay, so again, if you use the rules we've learned before, you will get the right answer. But let's see what this box tells us to do. It tells us that if we have something which is a squared minus b squared, can be written as a plus b times a minus b. So that means this one up here can be rewritten as, let's see, a in this case would be 2x, right? And so 2x 2x plus 6, 2x minus 6. Again, just following rules from the box, which you guys don't have to know. It's useful if you want to know it. Okay. Now, these are hardly ever see them coming out, but it's always worth knowing these things because it is in the notes, so I can't say it won't come out. Factoring, these are not trinomials in the way we've been looking at them before. Just trying to remember the word. We got polynomial, we got binomial. This is a polynomial with 3 terms. There's a specific word for that. Does anyone remember it? Polynomial with a power 3. I forget if there's a term. Anyone knows what word I'm looking for? A polynomial of power 3. So like x cubed, an equation with x cubed in it. I think there's a word. Is there a word for that? I think there probably is. Someone just chat GPT that thing or Google it or something.
That's
Cubic terms, yeah. I'm just looking for the word. Like it's a something nomial or something like that. There's a word I'm looking for. Can someone just look that up for us? Anybody with access to internet? Okay, in the meantime, I'm going to move on. You guys can read these at home. It's ways to simplify these things. Try the examples at home. A little bit of homework for you guys. And then we get to more important stuff here. If I don't get back to that flower pot example, I'll make a video and upload it for you guys. Because I guess we're kind of out of topic now with that thing. Did anyone find the word? Trinomial. We could call it trinomial, yeah. Okay, anyway. Anyway, now we need to learn about the principle of zero product, because factoring, many of you guys asked me about the quadratic formula. This is where we use that. This is where it can be used and you can get your marks for it, because here we asked to solve for x. So this comes from the principle of zero product, which says if I have something like a times b is equal to 0, and we asked, what does this tell us about a and b? Now let's try and think about it logically. Does it mean that a and b are both 0 here? Let's see, if a is 0, does this equation work? If a is 0 alone? Yes. Yeah. Yeah. So if a is 0, if a is equal to 0, then we get 0 is equal to 0. So that works. If b is equal to 0, same thing, right? If b is equal to 0, it also works. Then we get 0 is equal to 0, which is fine. So that's why we say, if you get something like this, you will say a is equal to 0 or b is equal to 0. Either one is fine. Right, so now using that, can we simplify things like this? When I say simplify, I mean, can we solve for a? Right, so, and I think the first step for something like this would be to factor. Often people try and divide by a, but that misleads us a little bit. We need to factor here, right? Because if you divide by a, you have to divide this side by a. No, that's not the reason it doesn't work. That's not the reason, but there's a reason. We'll get to that in a moment. Let's just do this first, and then I'll think about the reason. So we can factor out of 5a. And what we're left with is a plus 3. Right? Yeah, so if we just factored something out, then we won't get the entire solution set. We will be missing a value. Okay. So now we can say, according to the principle of zero product, which we just learned, we can say 5a is equal to 0, or a plus 3 is equal to 0. And from here, we can just solve these two equations to get a value for a. On the left-hand side, we can solve this one easily. That's just a is equal to 0. And we can divide both sides by 5. And we'll get a is equal to 0. On the right-hand side, we just move 3 to the other side and get a is equal to minus 3. Okay, so this is where the principle of zero product comes in. And you can always check your solutions by subbing them back into the original equation. So if I sub this back in here, we'll clearly get 0 on this side, which is what we want. So that works. If I sub -3 in, we will also get to 0. You guys can check that if you want to. Yeah, so it will work out. Because the second term is negative, so it will cancel out. All right, so let me ask you guys to use the same principle and try to solve the second equation here. Solve for R. All right, so if you need to factor, you can factor using the method we learned before. Okay, so guys, the first thing I did here is I factored using our R and S method. You don't have to use R and S unless they ask you to. But I'm just going to keep doing it to get us in practice with it. So if you want to use calculators, you can. It's fine. Okay, once you factor, firstly, anyone has any problems with the factors? Yes. So the formula should always be on. You need to see if it's negative E. E squared. C. So the C here should be 6, not 0. C is the last one. Okay, guys, we all good with this one? Good. Okay. All right, a word problem. Then maybe there's too many of these, so let's just do the second one. Yeah, okay. I'll give you guys to try this one. It's a word problem. Let's take 5 minutes or less to finish this one. This also seems like physics a little bit. Okay, guys, so let's do the solution on the board. So here the question says we have a toy rocket which is launched and its height is given by a certain formula. That formula is written here. We want to know how long, so in other words, we want to solve for t. T gives us time. So how long will it take for the rocket to hit the ground? Now hitting the ground means the height here is going to be 0. So in other words, if you just equate this formula to 0, or set h equal to 0 and solve for t, that's what we need to do. So I'll write it here, negative t squared plus 7t plus 4 is equal to 0. When h is equal to 0, what is the value of t? Well, there's a t squared here, sorry. Right? And now this becomes just a normal problem that we've been dealing with all this time. It's just factoring a trinomial. Right? Okay, so let's see, what can we do here? We can use the RNS method. You guys can use calculators, whatever you need to, unless specified that you must use RNS. Okay. Do you guys want to see me solve this one here? Or you solve? Yes. Yeah, same section. But here the good thing is you don't have to work out the formula, it's given to you. Yeah. Okay, all right. Anyone wants to see me work out this? Yeah. Factor this? Okay. All right, so let's see. Maybe easy thing to do will be to first divide throughout by negative and get rid of that negative sign. 2t squared minus 7t minus 4. That looks a little bit better. Now, can we find our R and S values? Let's see. So we need our R times S, which is equal to the C value times the A value, or negative 8. So R times S must be negative 8. R plus S must be negative 7. Right, okay. Is that right? Yeah. So let's find the factors of 8 and see which ones work. We could have, what just happened now? Where did we go? Okay, factors of 8, we could have, where can I write this? Let me write here on the side. Try not to move this thing. Negative 8 and 1, or 8 and negative 1, negative 4 and 2, or 4 and negative 2. Do any of these work? Yeah, I think the first one works. Minus 8 plus 1 will give us minus 7, so we can use that first one. Okay, but now we need to, remember, we need to rewrite this using our slightly more complicated version of the formula, which is to rewrite the middle term, the minus 7t, in terms of the factors we just found. So I'll rewrite this as 2t squared, and the minus 7t I'll rewrite as minus 8t plus t. Minus 4 is equal to 0. Now I can just factor. From the first two terms, I pull out a common factor. That will be 2t. And I'm left with t minus 4. From the second two terms, there's nothing to pull out, so we just leave t minus 4 as it is. Now we can factor one step further. We pull out a t minus 4. What we're left with is 2t plus 1 is equal to 0. Okay, that's the factoring done. Now remember, the principle of zero product says both of these could be 0. So to solve for t, we use that. Let me do that down here. We say t minus 4 is equal to 0, or 2t plus 1 is equal to 0. So on the left, I will write this as t is equal to 4 seconds, right? We're working with units of seconds. I think that's what they said. Yeah, okay. And on the right, we have 2t is equal to minus 1, or t is equal to minus a half seconds. Okay. So we got one more step here. Sorry? Yes, right. So we need to reject the second solution. We have to reject this one because time can't be negative. But even though mathematically this will give us a point on the graph, it will be backwards in time. So we ignore that one for physical considerations. If you plot this, it'll be a parabola that intersects at 2 points, and one of them will be negative a half. So it mathematically works, but physically, we can't go to that point. For this one here, I don't know, why am I doing that? Let's not do that. Okay, so this one is maybe a little bit more complicated, so maybe practice with this one at home. Does anyone have any questions for me so far? Okay, same idea we've always been using, just factor and solve. Okay, now we're looking at roots, and for some reason they want to take it right from the top. I think everyone knows what a root is, the basic idea. Okay, a root and a power of opposite operations. So let's see, words we have to know, which I think we covered already. A radical symbol. Have you guys heard that word before? Radical symbol. If not, it's just this thing that represents a root of something, right? So this thing that looks like a, some people say it looks like a division symbol. It's just that thing there, right? It's a radical symbol. And the number written inside that symbol is called a radicand. So just remember those words for multiple choice. Okay, so now we talk about a thing called a principal root. Again, a word you need to know. And this comes from the idea that if I take the square root of 4, for example, the answer is technically plus minus 2, which means it could be positive 2 or negative 2. This, so in other words, I could write this as square root 4 is equal to 2 or minus 2. Right? I want you guys to see that because opposite operations, right? If I take the square root of 4, it should give me the thing, which if I square, I will get back to 4. So both of these things, if I square them, I get back to 4, right? Negative 2 squared is 4, 2 squared is 4. So these are both solutions, but the principal root is always the positive solution. So just remember that. The positive one is the principal root. Okay, just hang in for a few more minutes, guys. I won't go too much longer. I can see we're reaching that point of the day. Okay, principal root. If you're not hearing what I'm saying, just read up. All the definitions are here. Right, everything you need to know. Okay, and maybe this is an important one, knowing how to write the square root as an exponent. I think we covered this, but if we didn't, the square root of 4 is the same as 4 to the power half. So a square root is the same as a half power. Just remember that. Okay, and I'm just thinking maybe these are going to be a bit too much now if you guys are not feeling it. It's a lot of important stuff here. Can I give you guys some homework then to read at home? Okay. So let's see. Okay, so this is, you guys have the slides, right? It's all on R. I haven't posted this one. But guys, if I forget to post anything, just tell me. So I'll post this one. And page 45, just tell you guys what to read and try the examples as you read. Page 45 up until page, not too much. Page 50. 45 to 50, right? Not too much. Just read those and try the examples. All right, then I will set you guys free and I'll see you next time. Yeah.